So we have frauds in a variety of areas. Everyone has probably heard about credit card fraud. There are billions of transactions worldwide every year, and you have to decide in a fraction of a second, is this fraud or not? Obviously, there cannot be a human in the loop. It has to be automated because of the sheer number. And then you have to flag risk cases where there's a suspect of fraud, and then you get the human in the loop to either cancel the transaction, prevent it, or follow up. Another area is tax fraud. In the European Union, for example, there's a big problem with value-added tax. Like companies are allowed to withhold the tax instead of directly paying it. And if there's deals between companies and you have like a chain of companies, sometimes this keeps on going until the tax should be paid by the last company, but that suddenly disappears or is bankrupt or something. So there's a lot of money actually withheld or withdrawn from the European Union in that way. Obviously, there's other types of tax fraud, income tax fraud, corporate tax fraud, etc. Other areas are in large purchase processes in the retail industry or in procurement and large corporations, where there's a lot of flow of materials, a lot of transactions. There always is a risk that some of them are not legit and that some of them should be prevented. Another big area is insurance fraud. Maybe you have heard about car insurance fraud, where some people fake an accident so they can collect money from the insurance, like provoking accidents or actually completely faking them, like there is no real accidents at all. Or fire insurance, where people set their own house on fire to collect the premium. And another big area is actually healthcare fraud. So for example, in the United States, there's a system in some of the states called Medicaid, Medicare, which is about helping people that cannot afford their own health insurance. So if you're without a job, you don't have enough income, then you can actually ask particular states that they provide for you. And for example, one of the bigger states has a budget of $6 billion every year. And internal estimates are that 10 to 20% of that are fraud and waste. In other words, 1 billion every year goes to the wrong targets. Doesn't help the people, it just goes in the wrong pockets. So that should be a motivation that this is actually relevant. It's not just peanuts, it's really big numbers actually, even if most people may not be aware of that. Okay, next slide please. So yeah, well, what are the challenges here? One challenge is obviously the fraud patterns are changing. We're not dealing with stupid people, we're often dealing with highly intelligent people. For example, if in the healthcare industry, a doctor commits a fraud, they typically are quite intelligent people and they think about what are easy patterns that are easy to detect and they try to use other patterns, obviously. Or if certain fraud patterns don't work anymore, then the fraudsters come up with new patterns. And there's different areas in the medical space, for example, who can be the fraudster. It could be the patient who collects some medications and then resells it instead of using it because it doesn't really need it. So like a drug reseller in that sense for medical drugs. Another source can be pharmacies that actually fake sales and then sell the same thing twice, once just on paper and once really, so they actually double their income. Or care providers that, let's say, they build a system for wheelchairs that they never delivered and things like that. Then you have the doctors themselves who sometimes build stuff that has never been delivered, or pharmacy products that have never been delivered. And then you have even sometimes networks of doctors where they pass, for example, social security numbers of patients from one to another where they already know it works quite well. There may be simple cases, social security numbers of persons who have already died. That should be detected, you would think, but that every once in a while pops up actually as a problem. Then there is those of well, let's say patients and doctors working together. Like, hey, if I'm allowed to bill you on this medication that I didn't provide you, I give you half of the cost that it would be able to get reimbursed from the health insurance. So there's all types of patterns, and it's quite a challenge actually to keep up. It's like a race. Whenever you have a system to find more fraud patterns, actually the other side has new ideas how they could camouflage their fraud and could still commit it. So there's a large variety of fraud types. And there's also a large variety of potentially relevant data. To give you just an idea, if you talk about, for example, pharmacy fraud, there have been cases where pharmacies have been reimbursed even if they already went out of business. So you'd have to check the business register or their, well, if they're still allowed to actually sell stuff. So that may sometimes means you have to check geo-information. Or of course you have to check all transactional data. Sometimes you have to check textual data for clues because that might actually give some insight and so on. So there's a large variety of data, large volumes of data. Next slide, please. So now, how can we help with technology? How can we automate things? How can we leverage something like machine learning? And that, I want to start with a quick question. Can you predict the future? Who can do it? Okay, not so many. Next slide, please. Okay, so imagine we're at a reception, standing there at the tables. Everyone has a glass in their hand, maybe champagne, maybe water, and you see that one person lets their glass slip, and before the glass even touches the ground, you probably look like, because you predict the glass is going to break. How can you do that? You know how high it is. It's like falling from, let's say, 1.20 meters. You know it's a very thin glass, it's a hard floor, and you somehow predict this will probably break. So over our life, we have seen a lot of data, a lot of observations. Glasses fall from different altitudes, with different thickness of the glass, different hardness of the floor. So we could actually derive patterns that tell us, given certain attributes of the whole situation, like the height of the fall, the hardness of the glass, and the hardness of the floor, etc., we have a probability at least with which we can predict whether the glass is going to break. Next slide, please. And one more. Thanks. So we're looking for patterns that can be physical things, or in our case, fraud patterns. And we want to automatically find them, or leverage expert knowledge and embed that, or combine these two things. Next slide, please. There's easy examples, for example, from the mobile phone industry or the electricity industry, where companies try to prevent customer churn. They try to predict, will this customer be loyal, or is he going away to another company? And the same thing on fraud. I have millions of transactions for millions of patients, and I have to decide which one is a fraud, which one is not. Okay, next slide, please. Another example for this kind of prediction is predicting sales volumes. How many books of a certain type will I sell at which store? There's actually quite good models for that. So for any kind of book in a bookstore, they do predictions, how often it will be sold, so they can have them in store. Not necessarily at the individual store, but if they don't have it, they can order it and they have it the next morning, because there are central storages across the country, and it's predicted how much it will be needed at each location. Next slide, please. Okay, we can skip. So there's different type of analysis. You're looking at the past, understanding what has happened. How much of a book did I sell in a particular store? Or which type of fraud did I observe in the past and recognized? Obviously, there's also unrecognized fraud. This is looking back. It's called descriptive analytics, business intelligence, this kind of analytics. The next step, diagnostic, is explaining what happened. How is the correlation of things? How are things related? Trying to explain it, how it works and how it can be detected. This is a typical data mining situation there. And then the next step is actually trying to anticipate, trying to prevent it. Like in the case of the credit card transaction. Before you transfer the money, you want to do a very quick check. Is this okay or not? And if you have doubts, then maybe you call the owner of the credit card to check if it's really him doing the transaction. And then, of course, all the knowledge and all the prediction is worthless if you don't do anything. So actually, you need recommendations what to do. And in situations where you have extremely large numbers, like in the credit card fraud case, you probably want to automate the action. You immediately want to stop the transaction and then ask before anything else happens. In other cases, when we talk about big decisions, strategic decisions, then you probably want to have the human in the loop. So either as recommendations or automated action. Next slide, please. So who are we and what do we have to do with that? RapidMiner is an open source platform for data mining, machine learning, and predictive analytics. It has a big marketplace. That means, first of all, it's open source, has open interfaces. And on the marketplace, like on an app store for smartphones, you can actually download extensions that either we developed or any other company or university around the globe developed and makes available there. So if we don't provide it, there's a good chance that someone else on the world provided it, and you can download it from there. And our goal is to make machine learning and data science as simple as possible. So you don't have to know programming like in Python or R. You can seamlessly integrate Python and R scripts, but you don't have to. You can just visually drag and drop individual algorithms. So you have an analysis workflow and then execute that directly. Okay, next slide, please. Well, open source is cool because you can get the solution for free. It's also cool for us because it means the user base is growing really rapidly. We started with a few users, with ourselves, when we built a tool to help ourselves in our research projects back in 2001. And then in 2004 and 5, companies started to ask, hey, do you do consulting and services around that? And then at some point, we started the company in 2007. And now we're up to more than 300,000 registered users worldwide in over 100 countries. Okay, next slide, please. Okay, let's skip this one and the next two. so we can focus a bit more on the other stuff. You can have the slides afterwards as a PDF if you like. So if you look at Gartner, they see us as one of the leaders among big companies like IBM and SAS, for example. Next slide, please. Same with Forrester, and you can see we're moving ahead quickly. I think company is just 10 years old and we are already at the top. Next, please. Also usability, actually there we are ahead of the classical providers. Next, please. So let's get back to the real stuff. I don't want to spend too much on the company advertisement. Fraud detection and prediction. How can I actually do that? What are typical steps that I could take to get this going? Next slide, please. Machine learning has a variety of algorithms to offer. There's one group of algorithms they're called supervised learning. You have a teacher that already knows something about the problem. For example, you have a domain expert that can tell you, well, from this 1 million transactions in the past, these 10 were fraud cases. So you put a label on them. And then the algorithm can learn to automatically classify new cases, whether they match the fraud pattern or one of the fraud patterns, or whether they are a normal case, so to say, a no fraud. So that's quite interesting for obviously detecting cases of known fraud patterns in new data. Then there's regression algorithms. They have numerical target variables that try to predict numbers. For example, for a particular doctor, what do I expect how much he gets per month for reimbursement for medications? And then I see suddenly he's asking for 10 times as much. Maybe that's okay because maybe he has patients that require very expensive care. Then it's completely okay, but it's worthwhile checking if it jumps like that, just as a very simple example. So being able to predict numbers can help to match expectations and reality. And if there's a big gap between what you would expect normally and what's actually happening, that might be a good pointer for a human to investigate. Okay, and actually the algorithms don't decide if it's fraud or not. They just point you to, hey, this is a high risk of being a fraud, and then the human still decides that. Then there's grouping of cases, finding similar cases, like you have something that looks strange, and then you can say, hey, show me similar stuff, like clustering or segmentation of things. There's association analysis. You probably all know Amazon as an online retailer, or when you select a book, Amazon starts to recommend other books or other products. For example, if you select a digital camera, they'll automatically recommend, well, do you want an extra battery? Do you want a camera bag? Do you want a memory card with the camera? And you say, yeah, I need all that. And the same kind of technology you can apply to fraud events. Are there things that are typically co-occurring with the fraud events, like something that could help me to predict it or to detect it? And then you can use this kind of thing to generate association rules to find related events or observations. And then one problem remains. I said if you have a domain expert that can point you to fraud, but what if it's a new fraud pattern? Nobody has seen it before. How do I find that? There's another group of algorithms for what's called outlier detection or anomaly detection. So basically you observe millions of transactions and suddenly you see things happening that are kind of different. Either the amounts are unusual or maybe the way the things are routed in the transactions is unusual. Maybe there's kind of hotspots, pharmacies that wire a lot of stuff, or you find, for example, that a group of doctors shares exactly the same patients or has a very high overlap. That might be natural, but that might also be a reason to take a closer look. And then along this, you have topics like, of course, I want to automate things, I want to optimize the things, like I want to pick the best machine learning algorithm, I want to optimize the parameters, find the best pre-processing of the data, etc. And then you want to automate the deployment. Okay, next slide, please. Okay, so you can approach this in several steps. Let's say the typical approach, if you don't use any IT or just very little IT, would be you randomly pick samples from your transactions or from your entities that you're looking at for inspection. So for example, maybe you have a rule of thumb, every company gets inspected once every 10 years, randomly. Or looking at millions of patients, maybe you randomly pick 100 patients a month, and hopefully you find the fraud cases randomly. That's the classical approach. Obviously not very worthwhile. It's not very successful in terms of recognition rate. So, but now if you have domain expertise, you know certain fraud patterns, the first step could be to just try to encode the fraud pattern into some variables that give you clues about it, like for example, amounts of transactions aggregated over some period, number of doctors interacted with for a patient and things like that, and then combine that to something that you could call a risk score. There's not really machine learning yet. This is just an expert exercise, someone who knows the domain. But it's the first step to automate it, because as soon as I can have such a risk score, then I can kind of sort all the patients, all the doctors, all the companies I'm monitoring by how much risk is there that this is as a fraud case. And then instead of randomly picking cases, you start with the top priority cases, so your chance of actually finding fraud cases is much higher, even before starting with the data mining. But now, obviously, I want to explain how you can use data mining here. That would be the next step. Once you have known fraud cases, and after asking the experts and trying to embed their knowledge, you would actually use machine learning then for a classification task and say, hey, try to find the same fraud pattern that I've seen in the past in my new data, like every month, every week. And then point it out to me. Again, you can use that either as classification, or if you use the confidence of the classification algorithms, how sure is the algorithm that this is a fraud, you can again have a ranking by some prioritization risk score. Then the next step is identifying unknown fraud patterns by, for example, anomaly detection. Like I said before, try to find very unusual things and maybe attach also a score to that. Another step then is also network analysis. Instead of looking at the individual only and some scores for the individual, also look at who is he interacting with, which pharmacies is he visiting. If a patient goes to 20 different pharmacies to collect the same drug everywhere, it's kind of strange. Maybe he does it to kind of not buy too much of the same drug at the same time at the same pharmacy, so they don't recognize him again and again, but maybe it's a fraud pattern. Or if you see the same patient at 5 different doctors in different locations, kind of strange too. And things like that. So looking at the network makes definitely sense. So for example, find doctor networks that share social security numbers of patients collaborating in fraud. Obviously, I already said there's also the option to predict things, like predict expected amounts for reimbursements and stuff. And if you find there's a big gap between what I'm expecting and what I'm seeing, this is also like an alarm signal. And then if you want to get more advanced and sophisticated, as I said in the beginning, your opponent is very smart, and there's a machine learning technology called adversarial learning, where you actually, it's like a game. You try to get better testing yourself with the adversary. Obviously, like I said before, there's various types of data, so looking at textual data is also relevant. Maybe there's patterns in the textual descriptions of the transactions that gives me a clue or indication of fraud. There's also something called process mining. So you look at all the digital traces a person leaves in an IT system or the business process leaves behind, and you automatically analyze that. That can be used to make organizations more efficient. For example, to find bottleneck in production lines, or to find bottlenecks in organizations. Why does it take so long to get this done? And then you see where the problem is. But it can also be used to find unusual things. Things that have high interaction with a lot of others, or unusually high things. Or again, the network effects. Okay, next slide, please. I think we can skip that one. Skip the slide, please. We can also skip that one. Next, please. Okay. We have a little bit of time left, so I have a very quick idea. If you look at credit card fraud, for example, next slide, please. You have different types of data entities. Next, please. Okay. And again, you can look for supervised, for known fraud patterns, or for unusual behavior, unsupervised fraud patterns, like in the medical space. And of course, you probably want to keep also some random samples in there, because maybe what your prioritization or your risk score does is not perfect. And if you only 100% go by your risk score, then you miss the things that your algorithms missed. So a little bit of sampling, random sampling is always good, so you have a chance to find things that the algorithms did not recognize yet. So the human can help and see, hey, this random finding actually is a fraud, and then the algorithms can actually improve. So you have a continuous learning. Each human classified case becomes an improvement of the training data. Next slide, please. I think we skipped that slide. Running out of time, so let's skip that one too, and the next two as well. And okay, we can skip that one too. And yeah, maybe I talk a little bit, last 20 seconds according to the timing, about the platform again. It's visually oriented, so you design your workflow by just dragging some little boxes, connecting the boxes to show how the data flows goes. You can integrate data from various sources, let's say transaction databases, free text fields in some, yeah, let's say reimbursement proposals, etc., and combine that. And then you can run it either on your machine or on a server. So please, next slide. Next slide, please. You can actually integrate data of all kinds of sources. Can be from the internet. For example, maybe you check geo information to Google Maps or to some other service that you have available. You can connect to public databases of information that is about doctors, about typical treatments, about typical costs for things. Of course, you can tap into your own databases. You can process all types of documents. Maybe you have information in PDF documents and Excel sheets, in NoSQL databases, etc. Next slide, please. Next. Oh, okay. One back, please. And another interesting aspect is, okay, I can do without the slides, what we call wisdom of the crowd. So you connect your experience, and a lot of people are willing to share. We have a community of, I said, more than 300,000 users using the tool, but there's also interaction going on where they discuss things, ask questions in the community forum, get replies. And also, if they allow, we have this mechanism similar to Amazon that basically helps to recommend what step should you do next in your analysis. What operator, which machine learning algorithm, which data preprocessing should you select to get the best result. And so it's like the market basket data Amazon collects. These things were brought together. So we're not looking at the customer data. We're not even looking at the concrete process the customer is building. We're just looking at what's typically used together, and only if the customer allows us to transfer it. But then, across the whole community of hundreds of thousands of users, this is a lot of implicit knowledge and can be used for generating advice. Thank you very much. Please go back to slide 1.